wabarakatuh. Hello everybody. Welcome to our presentation. My name is Shela Rahmawati and I am accompanied by my members. There are Hani, Angel, Desintha, and Yuliana at our group number 2. The topic of our presentation is quadratic equation and application quadratic equation.
Hello, my name is Hanifatul. Okay, let's start. What we learn today we learn about quadratic equation and application of quadratic equation. Next, definition. A quadratic equation is a polynomial equation of the form ax squared plus bx plus c is equal to 0, where a and b is coefficient, x squared and x is variable, c is constant. Additionally, a, b, and c are non-values. A is not equal to 0, and x is a non-value or we do not integer. Next, for your information, the name quadratic comes from quadratic square because of real bracket square, or like x squared. It's also called an equation of degree 2 because of the 2 on the x. Next, here are some examples. First, 2x squared plus 5x plus 3 is equal to 0. That, in this one, a is equal to 2, b is equal to 5, and c is equal to 3. Second, x squared minus 3x is equal to 0. That, this one is a little more tricky. Where is a? Well, a is equal to 1, as we can usually write 1x squared. And b is equal to minus 3. And where is c? Well, c is equal to 0, so it's not shown. Third, 5x minus 3 is equal to 0. That, oops, this one is not quadratic equation. It is missing x squared. In other words, a is equal to 0, which means it can't be quadratic. Next, hidden quadratic equation. As we saw before, the standard form of quadratic equation is ax squared plus bx plus c is equal to 0. But sometimes, quadratic equation does not look like that. For example, first, in this case, x squared is equal to 3x minus 1. Move all term to left hand side. In standard form become x squared minus 3x plus 1 is equal to 0. So, a is equal to 1, b is equal to minus 3, and c is equal to 1. Second, in this case, 2 multiplying by w squared minus 2w is equal to 5. Expand under the bracket and move 5 to left. In standard form become 2w squared minus 4w minus 5 is equal to 0. So, a is equal to 2, b is equal to minus 4, and c is equal to minus 5. Third, in this case, z multiplying by z minus 1 is equal to 3. Expand and move 3 to left. In standard form become z squared minus z minus 3 is equal to 0. So, a is equal to 1, b is equal to minus 1, and c is equal to minus 3. Next, there are various methods on which a quadratic equation can be solved. Following are the methods of solving a quadratic equation. First, factoring. Second, completing the square. Third, quadratic formula. The first method is factoring. Let us see how to use the method of factoring to solve a quadratic equation. Example, multiplying x plus 4 and x minus 1 together. Cut or expanding, that's x squared plus 3x minus 4. We can see that x plus 4 multiplying by x minus 1 expanded to x squared plus 3x minus 4. And x squared plus 3x minus 4 as vector x plus 4 and x minus 1. So, x plus 4 multiplying by x minus 1 are vectors of x squared plus 3x minus 4. Just to be sure, let us check. X plus 4 multiplying by x minus 1 is equal to x multiplying by x minus 1 plus 4 multiplying by x minus 1 is equal to x squared minus x plus 4x minus 4 is equal to x squared plus 3x minus 4. The answer is right. Yes, x plus 4 and x minus 1 are independently vectors of x squared plus 3x minus 4. Okay, let us try another example. Find the vectors from equation 6x squared plus 5x minus 6. Step 1. AC is 6 multiplying by minus 6 is equal to minus 36 and B is 5. List the positive vectors of AC is equal to minus 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. One of the numbers has to be negative to make minus 36. So, by playing with a different number, I find that minus 4 and 9 work nicely. Minus 4 multiplying by 9 is equal to minus 36 and minus 4 plus 9 is equal to 5. Step 2. Rewrite 5x with minus 4x and 9x. Become 6x squared minus 4x plus 9x minus 6. Step 3. Factor first 2 and last 2. Become 2x multiplying by 3x minus 2 plus 3 multiplying by 3x minus 2. Step 4. Common factor is 3x minus 2. So the result is 2x plus 3 multiplying by 3x minus 2. Let us check. 2x plus 3 multiplying by 3x minus 2 is equal to 6x squared minus 4x plus 9x minus 6 is equal to 6x squared plus 5x minus 6. Yes, the answer is right. That's all of me. Thank you for your attention. Bye.
Hi, my name is Rahmawati. Okay, I will to explain with you about completing the square. By completing the square, especially product formulas for perfect square trinomials. Right, and there is a below is a plus b square equals a square plus 2ab plus b square, or you can use a plus b squared equals a square minus 2ab plus b squared. We use this formula to help us solve by completing the square. Next step to solving quadratic equation by completing the square. A equals 1. You can use that when give a quadratic equation a x2 plus bx plus c equals 0, we can use the following method to solve for x. Step 1. Rewrite the square quadratic equation so that the coefficient of the leading term is 1 and the originally constant coefficient is on the opposite side of the square sign from the leading and the linear terms. Yes, you can complete over to complete the square. You can find c. First of all, you will find c. Complete the square C. Correct in formula is a squared plus 2ab plus b squared is easily factored to a plus b squared. Yes. For complete the square, you can find c first of all. And step 2, to make it x squared plus bx plus c to a perfect square, we will find c with the formula easy. Alright, we will assess to find the example square. X squared plus 10x plus c to perfect square. We will find c first of all. C equals a half times b squared equals a half times 10. B is equals 10 squared. Yes. Equals 5 squared equals 25. Yes. Next, x squared plus 10x plus c. We will have done to find c. Result is 25. Yes, you will write kind easy. X plus 5 squared. It is a factory of x squared plus 10x plus 25. Right, next. Solve quadratic equation by completing the square a not equals 1. To complete the square a x squared plus bx plus c equals 0, spirit variable and numbers divided by everything. Find c and add to both sides. Okay, next, the example of square. X squared minus 15x plus 18 equals 0. First of all, you divide it by 3. Alright? 3x squared divided 3 minus 15x divided 3 plus 18 divided 3. Oh, sorry, it is equals minus divided 18 divided 3. Next, you will find x squared minus 5x plus 25 divided 4 and minus 6 plus 25 divided 4. How we find 25 divided 4? Yes. First of all, we will find C equals we will use a formula a half times B squared equals a half times 5 and equals 5 divided by 2 square equals 25 divided by 4. Yes, how we find that? You will find formula to find C. And next, the result is a root of x minus 5 divided by 2 square equals square root a half 4. And next, you will to calculate x minus 5 divided by 2 equals plus minus a half, and then you will calculate them. X equals 5 divided by 2 plus minus a half, and the result is x equals 3 and x equals 2.
Hello, my name is Ceria Myrela. I'm from Group 2. I'm talking about the quadratic formula. As you might guess, to solve for the roots or source quadratic equation. Quadratic formula is a simple way to find the quadratic equation. There are certain quadratic equations that cannot be easily factorized, and here we can conveniently use the quadratic formula to find the roots in the quickest possible way. The root of the quadratic formula further helps to find the sum of the root and the product of the roots of the quadratic equation. The two roots in the quadratic formula are presented as a single expression. The positive sign and the negative sign can be alternatively used to obtain the two distinct list of important formula to helpful find the quadratic equation. 1. The standard form of a quadratic equation is ax squared plus bx plus c equal to 0. The discriminant of the quadratic equation is d equal to b squared mean for ac. For d more than 0, the roots are real and distinct. For d equal to 0, the roots are real and equal. For d less than 0, the roots do not exist or the roots are imaginary. The formula to find the root of the quadratic equation ax squared plus bx plus c equal to c. Like this, the quadratic formula tells us that the solution to this equation r is equal to negative b plus minus the square root of b squared minus 4ac all of that over 2a. The discriminant b squared mean for AC, it is called the discriminant because it can discriminate between the possible types of answer. When b square mean for AC is positive, we get the two real solution. When it is 0, we get just one real solution. When it is negative, we get a pile of complex solution. Just put the values of A, B, and C into the quadratic formula. Do the calculation. Example, when the discriminant is negative, solve x squared mean 4x plus 6.225 is equal to 0. Coefficients are A equal to 1, B equal to mean 4, and C equal to 6.25. This discriminant is negative, so B square mean for AC equal to mean 4 times 1 times 6.25 equal to mean 9. Use the quadratic formula. X equal to minus mean 4 plus minus roots mean 9 times 2 equal to roots mean 9 equal to 3i, where I is the imaginary number, roots mean 1. So x equal to 4 plus minus 3i2. So let's say we have 5x squared plus 6x plus 1 equal to 0. This situation is A equal to 5, B equal to 6, and C equal to 1. And let's just put in the formula to solve. What we do get? We get x equal to mean b plus minus roots b squared mean for AC over 2a. Negative b is mean 6 plus minus the square root of b square. B square is 6. Square means 4 times a, which is 5 times c, this is 1. Then all of that over 2a. A is 5, so x equal to mean 6 plus minus roots of 36 mean 20, that over 10. X equal to mean 6 plus minus roots of 16 over 10. X equal to mean 6 plus minus 4 over 10. 4 plus minus 6, 4 over 10 is mean 0.2. And for minus 6 minus 4 over 10 is mean 1. So x equal to mean 0.2 and mean 1.
Assalamualaikum warahmatullahi wabarakatuh. My name is Desintha Mayesti and I'm from group 2. I'm here to explain about application of the quadratic equations. But before I start, I'm sorry if there will be a lot of annoying noises because I can't control situation right now. First, we have Pythagorean theorem. A long time ago, a Greek mathematician named Pythagoras discovered an interesting property about right triangles. The sum of the squares of the length of each of the triangle's legs is the same as the square of the length of the triangle hypotenuse. This property, which has many applications in science, art, engineering, and architecture, is now called the Pythagorean theorem. From this picture of an ABCD right triangles, if A and B are the lengths, of the legs of this right triangle, and C is the length of the hypotenuse, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. First leg square plus second leg square equals to hypotenuse square, or A square plus B square equals to C squares. Now we have an example of this case. If there a right triangle in which 12 cm and 16 cm are the length of two legs of this triangle, then find the length of x. Based on this picture, we know that x is the hypotenuse. By using Pythagoras, the sum of the two smaller squares is equal to the square of the hypotenuse. This gives us 12 square plus 16 square equals to x square. 144 plus 256 equals to x square. 400 equals to x square. Then root of 400 equals to x. Now we get that x equals to 20. So the length of x is 20. Second, we have area of rectangle. Suppose the area of a rectangle 104 cm square and the length is 5 cm longer than the width. Find the length and the width of the rectangle. So the answer is the length is 5 cm longer than the width. It means the length equals to the sum of 5 and the width. Let V as the width, so the length will be V plus 5. By using the formula for the area of a rectangle, or area equals to length times width, we can find the length and the width of that rectangle. 104 equals to V plus 5 times V. 104 equals to V square plus 5V. 0 equals to V square plus 5V minus 104. So V square plus 5V minus 104 equals to 0. Use the factorization to find V. V square plus 5V minus 104 equals to 0. V plus 13 times V minus 8 equals to 0. So we get V plus 13 equals to 0, V equals to minus 13, or V minus 8 equals to 0, so V is 8. There is no width, nor length is negative, so the valid width equal to 8. The length equals to V plus 5, so the length is 8 plus 5, and it is 13. From that, we get the length equals to 13 cm and the width equal to 8 cm.
In everyday life, many problems are solved using the application quadratic equations. Problems involving quadratic equations can generally be solved by the following steps. Steps 1. One of the unknown quantities is expressed in a certain variable, for example, x or another variable. Step 2. Make a mathematical model in the form of a quadratic equations from known data. Step 3. Solve the quadratic equations by factoring perfect square or formula ABC. For more details, let's go straight to the example. Example 1. The sum of two whole numbers is 20 and the product is 96. What are the two numbers? Let's answer. We assume the numbers are A and B. So we have A plus B equal 20. and a, b equal 96. If we have two equations like this, we usually use eliminations and substitutions. Now we will try to use substitutions method. Firstly, we change the first equations from a plus b equal 20 to a equal 20 minus b. And then we can substitute the value into the second equations. Let's do it. AB equal 96. Remember that a is 20 minus b, so 20 minus b times b equal 96. 20 times b is 20b, minus b times b is b squared, equal 96. And then we can move 20b minus b squared to the right side. So we can write 0 equal b squared minus 20b plus 96, or b squared minus 20b plus 96 equal 0. And then we factor into b minus 12, b minus 8 is 20, and 12 times 8 is 96. The next example. From the ground, a child jumps upward with an initial speed of 15 meters per second. The height or age of the child jump after 3 seconds is expressed by the formula age equal minus 5t plus 15t. After how many seconds will the child return to the ground? Let's answer. From the above problems, we can see that the formula for age is age equal minus 5t plus 15t, and child steps on the ground is age equal 0. If we want to find the time, then we can write directly like this. Minus 5t plus 15t equals 0. This is already a quadratic equation. From here, we can solve by distributive factoring. So we have 5t times minus t plus 3 equals 0. 5t equals 0. So t is 0. And minus t plus 3 equals 0. Minus t equal minus 3. So t is 3. The conclusions. T equals 0 is child has not made a jump, and t equal 3 is the child returned to the ground. So the child will return to the ground after 3 seconds.